You know what, friends? Before we get into the modern definitions of IQ, let's just practice with the curve a little bit. I got a few problems I made up just to make sure we remember how to work our way around this curve. So let's take a look at the first one right now. Okay, so we want to figure out what percentage of people have IQs between 100 and 115. Okay, so what we want to do first on the curve, whenever I'm doing these manually, I like to draw the curve and then draw the numbers along the horizontal. It's kind of like what I do with discrete distributions, but I do those in Excel, often with a graph. But with this one, I can't make them in Excel, at least not well and not cleanly. So I do them on paper or on the board like this. Okay, we got to get between 100 and 115. And I want to know what percentage of the graph that I just shaded, which would relate to what percentage in the population have IQs between 100 and 115. It's important to remember that 100 is the average, and this 115 is the top of one standard deviation. That's important because you remember from your previous work that about 68% of all the data is between down and up one standard deviation, within one entire standard deviation. So if that's 68%, that means since the curve is symmetric, remember that, half of that 68 is going to be over here, and half of that 68 is going to be over there. So what does this tell us? It tells us about roughly 1/3 of the population, 34%, a third of the population has an IQ between 100 and 115. Okay, now hopefully you realize there's no more work to do here. Because between 85 and 100 has to be the same percentage as between 100 and 115 because of the symmetry of the curve again. A third of the population has average to 115, and a third of the population has slightly below average to 100. I say slightly below average, that's a very wishy-washy term. But between 85 and 100, 34% of the population, and between 100 and 115, 34% of the population. Okay, now we're going to go outside of 2 standard deviations. In order to do outside of 2, let's actually start with 2. Now we know that from 70 to 130 is 2 standard deviations, which means 95% of that data is in that range. But I want to know what's outside that range, not what's inside it, what's outside it. So I'm going to color that blue. This is the part that's down, below, and this is the part that's above. So these are the low IQ folks. These are the high IQ folks. Well, if 95% of it is within 2 standard deviations, that means there's got to be a combined total of 5% in the tails. That's a very important idea, those of you going to Math 244, the idea of how much area is in the tails. But that's all it is. So in other words, 5% of people have either an IQ below 70 or above 130. Okay, for this one, it's kind of like this last one, except I'm only interested in the ones that are above the 2 standard deviation mark. So there's 2 standard deviations. I'm not interested in these folks anymore. I'm only interested in those folks there. Well, we still have to think. We know that 5% is here and here, but we only want this side of the 5%. So what do? We cut that 5% in half. Because remember, the curve is symmetric. I'm sorry if I sound like a broken record there. But the curve is symmetric, right? You've got just as much on this side as this side. So your area is going to be 2.5%. So 2.5% of folks have IQs above 130. Okay, so now we got to go 3 standard deviations. And we did touch on this in the homework when we did standard deviations the first time. So this is not enough. We have to go out further. So I'm going to come down and up. I'm running out of board space. I hope you're okay with me squishing this into the plant over here. And really, the picture isn't as important as the numbers that go with it. So as far as scores go, if we go down, that's going to be down to 55 now. Put a line right there. And up to 145. Right there. Okay, good. Very good, very good, very good. Now, you might not remember this, and it's okay. These are the kind of things you can Google. But there's about 99.7% of all the data in a bell-shaped distribution between -3 standard deviations and +3 standard deviations. So up and down 3 standard deviations from the average. That's almost all the data. Except when you're talking about lots and lots and lots and lots of data in the population. 99.7 means 997 out of 1,000. That leaves 3 in every 1,000 in the tails. So in other words, let's use some color here. This little tail over here and this little tail over here combined make 0.3%. Doesn't seem like much until you extrapolate it out to a large population. Then it's 3 out of every 1,000, which is still a tiny fraction. But that's a lot of raw data points when applied to, for example, the entire population of the Earth. Now, I only want those that are above 3 standard deviations, not above or below. So this is total. So above 3 standard deviations is going to be half of that. Take this one off, and it's just 0.15%. Which, again, that would be, I guess, what, 1.5 out of 1,000, or probably easier to think about, 15 out of 10,000. That would be the prevalence of those. So out of every 10,000 people, 15 of them are going to have IQs above 145. Now, all of these operated on the same 3 percentages that we learned back in the day. It's just that we're kind of using them more. We're cutting them up more now. In the homework, we're going to cut up some of those modern IQ levels of giftedness. I did a little Googling and found some stuff. And then we're going to plant some seeds for the next day of the normal distribution, which is what happens in between. Like, this is nice when we are, 70, 85, 100. What if we had to come in here like 92 or like 98 or 120? What do you do then? We'll deal with that in the next day. But for right now, let's just practice some more of this stuff.